Good afternoon, everyone. How are you?
Good.
You asked that question anyway. Do you want the honest answer or?
Yes, I do. Unfortunately, there is some problem, looks like, in that projector. So I tried, but it's not working. So I couldn't finish marking your assignment yet, but hopefully I will be able to finish by this weekend. Okay? So before I start today's lecture, I would like to spend a few minutes on your assignment 2. You might have noticed that your second assignment is already available in Blackboard. Have you had some time to look at? Yeah. Okay. So this time it's 3,000 words. The case study Visa Incorporated. Almost the similar background. Now you are given with some specific questions this time. For example, is the number of card fraud experience the same across gender? Are there differences across age groups regarding card fraud? Then what is the average time lost in resolving a card fraud? How often does an online or offline fraud, card fraud occur? And last of all, do any of the customer satisfaction scores of response time, level of advice, the level of communication influence the overall satisfaction with credit card fraud? So basically, you need to analyze the data that you are given with respect to these questions. That means you need to answer these questions by analyzing the data. Some preliminary writing should be similar to that you had in first assignment. So I already received a couple of emails that, okay, we have written some of these contents in assignment 1, so is that all right if we just, what I should say, reproduce them, or if we just copy them in the second assignment, is that all right? Ideally, that's not all right. So what I will like that the content is same when you're providing a small background or if you are providing an introduction. So I understand that the content is same, but ideally you should not directly copy what you have written in assignment 1. So try to rephrase the sentence, okay? You can write down the same content, similar materials, similar sentences, but try to rephrase them rather than directly copying them that you have written in first assignment. In academic world, there is one term, I don't know if you are familiar with or not, that we call self-plagiarism. Have you heard this? Self-plagiarism. It means that once you're writing a document become like publicly available, then it becomes a public property. It becomes a public property. That's why even if it's your own writing, so next time if you are writing another article or another proposal or another report, although that's relevant to one of your previous writing, you are not allowed that you directly copy what you have previously written. So that is called self-plagiarism, so that's also not allowed. Okay? So ideally, try to rephrase the sentences. I just want to highlight a couple of issues that probably I believe you may be challenged with. First of all, if you look at question number 2 and 3 in the questionnaire, these are the question number 2 and 3. Number of times experienced offline card fraud in last 12 months. So respondents are expected to provide a number that how many times experienced card fraud, and another is not applicable. Not applicable means the respondent didn't experience any card fraud. Okay? And number 3 is pretty much similar, but this time it's online card fraud, and then it's 9999, it's not applicable. So it's actually a convention that when we have a missing observation, then we usually write down it in this way, like 99999. It's a convention, okay? So when you see that it's like 9999, it means that this observation is not available. It means that it's not applicable or missing observation or whatsoever. Now, it's important that how you deal this, okay? Like, number of respondents, they are saying that, okay, we are experiencing card fraud like 1, 4, 10, 11, 9, and then 999, these means not applicable, okay? So there are a number of ways you can deal with. One is you can simply get rid of them, okay? Simply get rid of them means you simply delete these observations, okay? That's the simplistic way. Another one is if there is some missing observation, then we can impute them. Like there are some statistical softwares that can be used to impute. We call it impute, means like you have 1,000 observations, but 1 or 2 missing in the middle. Okay, so there are some statistical softwares that will use the other information, that means other data set, to impute these 1 or 2 missing observations. That's another way. So if you want to go for this imputing, that's also all right, but I will suggest that if you impute missing observation, then provide a list of these imputed numbers, that these numbers have been imputed. But if you want to go for the simplistic way, just get rid of those missing numbers or the numbers those are not applicable. There is a recommended structure here. I think this is self-explanatory. I have provided a brief explanation under each of this heading, that what is expected: executive summary, introduction, research design, hypothesis development, statistical technique and justification, result, statistical, non-statistical interpretation, analysis and summary of the statistical result, recommendation. Okay. First of all, executive summary, I think you are familiar with. From the term, you understand that it should be a summary of your report. Okay. So apparently, it might be a simple task that's summarizing your whole report, but it's sometimes challenging that within the word limit or within a reasonable space, you need to summarize your full report. Okay. So you may need to write down your key points from your report so that you do not exceed your word limit. And particularly I am saying word limit about this executive summary or abstract because in most of the cases there is a very strict word limit for the executive summary or abstract. Okay, and it's in the professional world as well. Introduction, everybody understand. You should give a background of the case. And research design, when you have written your research design in your assignment 1, you actually have written the entire process of doing research that you were proposing. But this time, key information are already given. Okay, that means when you are talking about research design, you already see that there is a questionnaire given. So you know that a survey research will be followed. Now if you talk about sampling design, then sampling design and sample size, you will see that the sampling technique is given, sample size is given. Okay, that means it's already mentioned that this sampling design has been followed, this sample size has been used. So this information, the key informations are already given. What I will expect that in the research design section, based on these 3 or couple of key information, try to develop a story about the whole research design based on the information given. Do you get my point or not? What I want to say that, like when you are writing research design, you cannot only write, okay, we followed random sampling and these were our sample size. That's not enough. You should write down a full research design section based on the information that you are already given. My previous experience says that sometimes you write down something and you criticize that. Okay, don't do that. When you write down something, try to defend that. Okay, for example, in this case, it was mentioned that a random sample was followed. Sample size was, let's say, 2,000. Now, if you write that, okay, it was mentioned in the case that sample size was 2,000, but I don't think that's big enough. It's not the right thing to do. Okay, if you write that sample size is 2,000, try to defend that. Or if don't write that, okay, simple random sample was followed, but that was not a right technique. Okay, don't write in this way. If you write down that this is the sampling technique, this is the sample size, then try to defend that. And also, if you talk about survey method or survey research method, try to defend these strategies. So that's about research design. Hypothesis development, it's for each of these questions, you have seen there are 5 questions. For each of these questions, you should write down a null and an alternate hypothesis. Okay, in the last workshop, we have seen how do we write down null and alternate hypothesis. We will also see in today's workshop that how do we write null and alternate hypothesis. So clearly write down a null and an alternate hypothesis in the hypothesis development section. Then statistical technique and justification. Once again, it should be like question 1, question 2, question 3 in this way. Once you write down your hypothesis, that this is the hypothesis I will be testing for question 1, then you need to justify what hypothesis testing procedure will you be following. For example, we will be talking about t-test, correlation, regression, ANOVA, chi-square test, a whole lot of tests. You need to write down what statistical test you will be following and why. That is actually justification. Like you can remember in the last workshop, I tried to explain that when we are using univariate t-test, this is the situation, like it has to be interval scale variable and so on. So you need to justify what statistical technique you are using and why. That is statistical technique and justification. Then results and statistical and non-statistical interpretation. In this part, what is expected? Simply, if you run the test in Excel, you know you get an output, copy the output, paste it in your Word file. Okay? So the way it's done here. So Excel output can be easily copied and pasted in the Word file, and it can be easily edited. Okay? So copy the output, paste here, then provide a statistical and non-statistical interpretation. Once again, in the last workshop, I told you what we mean by statistical interpretation and what we mean by non-statistical interpretation. We will also be discussing it today. So when you are saying statistical interpretation, you first of all need to categorically write down that whether you accept your hypothesis or you reject your hypothesis and why. Okay? That you should write down in your statistical interpretation. I repeat, whether you accept or reject your hypothesis and why. Okay? Once again, I have seen historically that like you have null hypothesis and you have alternate hypothesis. What we conventionally try to do is we need to write down whether we accept or reject our null hypothesis. Okay? That means we reject our null hypothesis or we fail to reject our null hypothesis. Okay. Now, if you write that we reject our null hypothesis, instead, if you write that we accept our alternate hypothesis, literally both are same. Okay, like rejecting null hypothesis or accepting alternate hypothesis is same, but rather than writing that we accept alternate hypothesis, we write that we reject null hypothesis. Okay, that means what you do, what is your result with null hypothesis that you need to write down. That's what we conventionally write. And why we accept or reject our null hypothesis. For example, if p-value is less than the significance level or more than the significance level, that's why we accept or reject the hypothesis. That's a statistical interpretation, and non-statistical interpretation is like if you reject your null hypothesis or accept your null hypothesis, what you actually want to conclude from that. For example, if you say that this one and this one are same, average income level of male and female are same. If you reject your null hypothesis, it means that average income level of male and female are not same. So if in non-statistical interpretation, you need to write down that they are not same. So if they are not same, then definitely one is higher. So which one is higher? Average income level of male or average income level of female is higher than their counterpart. That you need to write down in non-statistical interpretation. Analysis and summary of statistical results. So in result section, you already have written all the results, all the statistical and non-statistical interpretation. In this section, analysis and summary, you just need to very briefly summarize your key results, addressing the key research issues. That means if you carefully read the case, you will find that there is key research issue. So when you are analyzing and summarizing your result, try to make a coherent story of your results and try to relate the key research issues. That this is how my key findings answer the key research issues. Last of all, recommendations. So try to make some recommendation here, okay? When you are recommending something, be mindful that each and every recommendation should be related to one of your key findings, okay? That means you should not recommend anything that's not related to your findings, okay? For example, if you find that young age customers are less satisfied with the services provided. So in your recommendation, you can write that the company should more emphasize on how to satisfy young age customers or how to attract young age customers. Okay. So if you find that, okay, among 2 or 3 services, the customers are less satisfied in relation to one particular service, you can say, okay, the company should emphasize more on how to improve this service. Okay? So each and one recommendation should be related to one of your key findings. And reference, last of all, you should follow APS 6 referencing style. That's a brief on what is expected, and you will know what's the submission date and so on. And in data set, you can see in one page the data is given, and in another page, these are the question 1, 2, 3, 4 up to 10, and the scale measurement of the data or of the variable is given. As I told you, that scale measurement is very important, like whether it's a nominal variable or ordinal or ratio or interval. This is given because this measurement scale will dictate you, or measurement scale will tell you what particular statistical technique you should be using. Okay? Any question? Then let's start our today's discussion. Our today's topic is bivariate analysis, differences between two variables. You can remember in the last class we started discussing statistical techniques in particular, and we have seen that broadly statistical analysis can be divided into 3 categories: univariate analysis, bivariate analysis, and multivariate analysis. So we already talked about univariate analysis in the last class. That involves one variable. And bivariate analysis involves 2 variables. That is our focus today and also in next lecture. So today, bivariate analysis difference between two variables, that one group of statistical tests we will be discussing. And in the next lecture, we will also be discussing bivariate analysis, but we will be focusing on relationship between two variables. Okay? So today's statistical techniques that we'll be learning are finding out differences among the variables or between the variables. And next class will be on relationship, whether two variables are related. Chapter 22 in our textbook. We have a couple of specific learning objectives. First of all, we will learn under what circumstance one particular bivariate statistical technique is suitable. Okay? As I already have mentioned that there are a number of bivariate statistical techniques. So which one should be used under what circumstance? That's the first thing we will be discussing. And then we will be learning about 3 bivariate tests today. One is chi-square test, then t-test, and last of all, ANOVA. Chi-square test and t-test we already discussed in the last class, but those were univariate chi-square test and univariate t-test. So today we will be discussing bivariate chi-square test and bivariate t-test. And last of all, that we didn't cover in the last class because that's basically bivariate issue. So that will be analysis of variance. So first of all, as the topic you see is the test of difference between two variables. So when we say test of difference between two variables, what we actually are testing. Test of differences between two variables can take place in 2 ways. One is we can simply test if there is a mean difference between two variables. If there is a mean difference between two variables. Okay? That means you have completely 2 different variables. For example, in our real estate data set, you probably remember we have 2 prices. One is sale price, another is advertised price. Now if you want to test that is the mean advertised price and mean sales price are different. Okay? Mean sales price and mean advertised price are different. In that case, you are actually testing mean difference between 2 variables. That's one way this test of difference between 2 variables can be taken place. Another way it can take place is there can be one dependent variable. One dependent variable can be divided on the basis of one classifactory variable. And we see that if that dependent variable is different in 2 groups. Okay? What I'm saying is one dependent variable, then it will be divided into 2 groups on the basis of a classificatory variable. For example, I already gave you this example. Like if you are testing that whether income level is different between male and female. Okay. Now you understand that you have one dependent variable. What's that? Income level. And you are dividing it into 2 groups on a, what I said is classificatory variable. Classificatory variable means it's dividing your sample into 2. One is male, another is female. So you are testing that one dependent variable, if different in 2 groups, where the groups are made on a classificatory variable. Okay? So these are the 2 ways. Now, let's see, as I said, that different circumstances and different tests. This is extracted from a textbook, so if you manage sometime, you can read your textbook carefully to get more idea. Here, if you look at this example carefully, first of all, in the extreme left, what we have is average driver distance. These are the driver distance of 3 golf players. We have 3 golf players, Dolly, Laurie, and Mel. Then their average distance, average drive distance is given. For Dolly, 135, Laurie, 150, and Mel, 185. Now, you have one research hypothesis or research question. For example, Lori hits hard drives farther than Dolly. That's your hypothesis. Lori hits hard drives farther than Dolly. Okay? Now, look what you are actually testing. You have two golfers. Who are they? Lori and Dolly. And they have number of drives, drives distance, and average of all them. For Dolly, it's 135, and for Lori, it's 150. Okay? And you are testing that if they are different. So, what's the variable here? Can you tell me what are the variables here? It's given in the slide, I understand, but still, what are the variables?
Distance and golf.
Distance, okay. And two golfers, okay? So you can take distance as a dependent variable, and that's divided into two golfers. That's a classificatory variable or nominal variable that I was talking about. So in this circumstance, what should we use? Probably you already know, as from our last class discussion, that when we have a ratio variable, ratio scale variable, and we are comparing mean, then we can go for t-test. But we need to have another decision whether we should go for an independent sample t-test or a paired sample t-test. Now, when you are comparing whether Lori drives farther than Dolly, and you have drives distance, number of observations for Lori and number of observations for Dolly, and you are comparing mean, what do you think? They have been drawn. These two variables or two data sets, they have been drawn from independent sample or they have been drawn from related sample?
Related? A related sample?
Related?
Or not?
Okay, look, what data we have? We have two players, Lori and Dolly. Now, in different tournaments, different matches, they have different distances. So this data set is actually representing, one data set is actually representing Lori's performance, another data set is representing Dolly's performance. So it's likely that they are drawn from independent sample. Yes or no?
Yes.
Okay. Now, if you look at the second example or second case, average 7-wood distance. Okay, average 7-wood distance. So it's 140, 145, and 150. Okay. So do you understand what does it mean? Average 7-wood distance. Actually, this average 7-wood distance is their average performance when they play for their club 7-wood. Their club is 7-wood. So this 140, 145, and 50, this is their average performance when they play for their clubs. And 135 that we have already seen, 135, 150, and 185, this is their average performance in their entire life. Okay. Now look, what is your hypothesis? Male hits her driver farther than her 7-wood. Okay, carefully look at this sentence. Male hits her driver farther than her 7-wood. Now you are comparing male's driver distance when she plays for her club and her driver distance in her whole life. So you are comparing which one is better, which one is higher, which one is lower. You understand? So in this case, still your variable, the main variable is the dependent variable is the ratio variable. That means the driver's distance. Okay. But you have now two data sets. One is for club, another is her entire life's performance. So what do you think? Now these two samples are they drawn from related sample or independent samples?
Well, shouldn't it be related, and I'm only thinking out loud because if she plays for that club, then they would have all of those statistics and everything she's ever done in her career.
Yeah. So now they are drawn from related sample. Yes or no? Because look, now you are comparing the performance of the same person. Same person in two different circumstances. So in this case, once again we will use independent sample we will use t-test, but now we will go for paired sample t-test. Okay? Is it making any sense? So you have a ratio variable and it's divided on a classifactory variable. If they are coming from independent samples, then we will use independent sample t-test, and if they are coming from related samples, then we will use related sample t-test. Now, if I just skip this one for the time being, sample size, then if we go to the next one, number of drives in fairway, okay? Number of drives in fairway, these are 4, 22, and 11. These are the number of drives in fairway, Dolly, Laurie, and Mel. So what your hypothesis is, Mel drives the ball more accurately than Dolly, okay? Mel drives the ball more accurately than Dolly. So what you are comparing now? And what are the variables you have?
Something to measure accuracy and something to measure quality.
You can remember previously we had one ratio variable. In the previous cases, we had one ratio variable, driver's distance, like how distant their drivers are. So driver distance, these are the ratio variable we had. But now what we are comparing is Mel drives the ball more accurately than Dolly. Okay, so the variable now we have is nominal. First one is golfer, Mel and Dolly. So it's nominal. We have two golfers. Then what we are testing is accuracy. Now we are not testing whether someone's drivers are more distant and someone's drivers are less distant. Now we are comparing accuracy, that's right, fairway, or left. So that's also a nominal variable. Yes or no? Okay. So we have, if we have two nominal scale variable, two nominal or interval scale variable, then we should use chi-square test. Okay, I think you can remember chi-square test we discussed in the last class. We will also be discussing today bivariate chi-square test. But in this case, we use chi-square test because we have two nominal scale variables. In previous cases, we had one ratio and one nominal. That's why we used t-test. But now both are nominal variables. That's why we use chi-square test. Okay. So I will leave the further discussion for this moment. Any question after this? So to summarize, what we have seen is when we are comparing means of ratio scale variables, we use t-test, and ratio scale variable is divided on the basis of one classifactory variable. We use t-test, and when we have two nominal scale variable, then we use chi-square test for comparing. Now, if we have understood some of these concepts, we will discuss more detail and theoretically, and we will see some examples as well. So, first of all, chi-square test. And the chi-square test that we will be discussing today is bivariate chi-square test. As I already mentioned that last class we talked about univariate chi-square test when we had only one variable. Today we will be discussing bivariate chi-square test, which is applicable for cross tabulation. If you can remember, cross tabulation represents a frequency distribution when we have more than one variable. That means we will have one row variable and one column variable, and if we represent the frequency of more than one variable, then it's a cross tabulation. Now, if I give you a recap, what we learned about chi-square test in the last class, we have seen that in chi-square test, we actually compare our expected frequency with an actual frequency. Can you remember that? For example, we have seen a restaurant example in the last class. We will just extend that example. In restaurant example, we have seen that the restaurants were located in two types of location. One is standalone location, another is shopping centers. Okay, so we actually collected data that how many of the restaurants were located in standalone and how many of them were located in shopping centers, and our expected frequency was there equally distributed. So one was equal distribution, another was what we actually got from our data. So we compared them and we find out that whether they are equally distributed. So actual distribution if they are different from expected distribution. Today when we discuss this chi-square distribution, we will be doing the same. We will be testing that if our expected observation or expected frequency is same as our actual frequency. However, now it is related to two variables. So if you can remember at the top, this example we already seen in the last class. There are 100 stores, 60 located in standalone location and 40 located in shopping center. That's what we actually received from our data. Okay. Now, as I said, that cross tabulation means there should be two variables. So we include another variable that's profitable and not profitable. Okay. So what we have done is, for example, 60 stores are located in a standalone location. Now the 60 stores are divided on the basis of profitability. For example, out of the 60, 50 are profitable and 10 not profitable. And the 40 stores, those are located in shopping malls. Among these 40, 15 are profitable and 25 not profitable. So this is the frequency distribution on the basis of location, and this is a cross tabulation because this is a frequency distribution based on location as well as profitability. Okay. In the last class, we have seen this univariate chi-square test. One variable, that's location. We have two variables now. One is location, another is profitability. Okay. Now the big question is what are the measurement scales of these two variables? I already have said that we have two variables now. One is location, another is profitability. What are the measurement scale? I mean nominal, ordinal, interval, ratio, because that's the first thing you need to understand before you go for a hypothesis testing. Can anyone tell me what are the measurement scales of these two variables? Yeah, you want to say something?
Me?
Yeah.
I think it's both nominal.
Both nominal.
Yeah.
Okay. Anybody else? Is there any different answer? Okay. So if you can remember that nominal, as we know that in the case of a nominal variable, we will code our data just by providing some numeric values to identify. Okay, and that will be like within a very small range. So one variable that is location, we have two locations, standalone and shopping center, so definitely that's a nominal variable. And other one is profitability. So why not it's a ratio variable? Because like profit, why it's not a ratio variable?
Just yes or no.
Good, because it's just two alternative answers we have, profit or no profit. That's why it's nominal variable. Now look, if we could collect actual profitability data, for example, we have 100 stores. What's the profit generated by store 1, 2, 3, 4, 5? I mean profit in terms of dollar. And then if we could prepare a frequency table like a standalone location and shopping center, and this is the average profit for this, then it will be a ratio variable if we could collect actual profitability data. However, now the profitability variable is only have either yes, no answer. Profitable, not profitable. That's why this is also a nominal variable. So we have two nominal variable. So when we have two nominal variable, I mean two less than interval variable, I would say in this way, two less than interval scale variable, then we use chi-square test to check if there is a difference. So to calculate chi-square test, what we do is, first of all, we need to prepare a contingency table. Okay, you can see how we prepare a contingency table. First of all, we have this 60, 40, 65, 35. The 65, 35, they are our column total, and 60, 40, they are our row total. Okay, and the total, this column total and row total both are 100. You can see this row total and column total both are 100. So what we do here, first of all, these 60, 60, 65, 40, then we are multiplying them by 40 into 35. So what we are doing is, you can see that we have 65 is the column total and 60 is the row total. Okay, 60, 65, column total, row total divided by 100. So this is our expected observation. Okay, so 60 into 35 divided by 100, that is we get 21. That's our expected observation. So in this way we calculate our expected observation, and we already have our actual observation. Okay, so once we have this actual observation and expected observation, then what we do is we simply calculate a chi-square statistics, the way we have seen in our last class. We calculate a chi-square statistic and we look at the p-value. If we see that the p-value is less than the significance level, we reject our null hypothesis. For example, in this case, our null hypothesis was profitability is not different. Profitability is not different based on location. Okay, profitability is not different based on location. So it indicates that either the restaurants are located in a standalone location or shopping malls, their profitability doesn't differ. So that was our null hypothesis. If we calculate chi-square statistic and look at our p-value, we will see that the null hypothesis is actually rejected. Okay, so if null hypothesis is rejected, what was the null hypothesis? That profitability doesn't differ on the basis of location. So if the null hypothesis is rejected, it means that profitability actually differs. If you look at the data, like without any testing, you can see that among this standalone location, we have 50 profitable. That means out of 60, we have 50 profitable and 10 not profitable. And shopping center, we have 15 profitable and 25 not profitable. So without testing, what's the impression we get? Like if we do not go any statistical test, just look at our data, what impression we get? Like they are equally profitable in a standalone and shopping center, or there is a difference? A standalone is much more profitable. Yeah, that's the impression we get. And if we go for a statistical test, we actually get the same answer, that the profitability is not same across the location. So profitability actually differs. So that's chi-square test. Now I already have said that what are the steps in a chi-square test. Then t-test. So as I already mentioned that you can use t-test in two different circumstances. One is when you are testing if the mean of two variables are different, or if you are testing that if one dependent variable is divided into two groups and if the mean between these two groups are same or different. These are the two ways we can use our t-test. And I also mentioned that if the two groups or two variables that we are comparing, if these two groups or two variables are coming from independent samples, then we will use independent sample t-test. One thing we should understand that this independent sample t-test are based on two assumptions. One is samples are drawn from normal distribution. So that's one assumption we make, that our variable is normally distributed, and also variance of two samples are same. We call it homoscedasticity. Variance of two samples are same. That means when we are comparing two variables or when we are comparing two samples, we assume that their variances are same. Although that assumption is, we need not to strictly follow this assumption, because particularly in Excel, we can test assuming either equal variance or unequal variance. Okay, so if we are unsure that if this assumption is a valid one or not, we can check both. That means assuming homoscedasticity, or the other one we call it heteroscedasticity. Heteroscedasticity means if the two samples have unequal variances. Okay, so generally we assume that the variances are same between two samples, but if we want, we also can test assuming unequal variances. And most of the business data that we will be encountering, we will see that the conclusion doesn't differ if we assume equal variance or unequal variance. So to go for an independent sample t-test, first of all, we need to answer this question. So first is the dependent variable interval or ratio? Okay. So as I told you that this is the first requirement for using a t-test, that either both of the variables have to be ratio variable, or one dependent variable should be divided in groups, but that dependent variable must be ratio variable. You get my point? Either both the variables have to be ratio, or the dependent variable that is divided in groups, that dependent variable has to be ratio variable. Then the second one is, can the dependent variable scores be grouped based on some categorical variable? That means if you have only one dependent variable, and that is an interval scale variable, the next question is this variable can be divided into some categorical groups? For example, male, female, let's say on the basis of marital status, married, single, or let's say employed, unemployed. So can you classify your ratio scale dependent variable into two groups? Is it possible to do that? The next question is, does the grouping result in scores drawn from independent samples? So when you are dividing them into different groups, I mean two groups, then are these two groups are drawn from independent samples? For example, as we say, male and female, or for example, we have seen two golfers. Okay, so are these groups are taken from independent samples? And last of all, are two groups involved in the research question? That means you are dividing your dependent variable, that's a ratio scale variable, you are dividing them into two groups. Question is, are both groups related to your research question? If your answer to all of these questions are yes, okay, I remind you, what are the questions? First of all, if your dependent variable is the ratio one, if your dependent variable can be divided into different groups on a classificatory variable, and are these groups are drawn from independent samples, and these groups are related to your research questions. If all the answers are yes, then we can use independent sample t-test. Okay? Any question, any problem? So as you will be doing your assignment, so it's important that first of all you understand your question, like as it was given that if the card draw different for on the basis of gender or for different on the basis of, I think, income level or so on. So first of all, you need to understand the dependent variable that you have, is it interval or ratio? Then when you are grouping it on the basis of gender, income level, and so on, if they are grouped on the basis of a categorical variable, if the groups are related or paired, and if the groups are related to your research question. If all of this, then it will be easier for you to choose a particular statistical techniques. So we already have mentioned that if we have yes to all of these questions, then we will use independent sample t-test. Now, if the groups that we do, that means our ratio variable is divided into two groups, and in the previous slide we have seen that if both the groups are coming from independent samples. Now, if all the questions answer is yes, but only the groups are not coming from independent samples, rather the groups are coming from related sample, we still use t-test, but now we will be using paired sample t-test. Okay, that means others answers are still yes. Dependent variable is a ratio that can be divided into groups, and they are related to research question. All answers are yes, except they are not drawn from independent sample. They are drawn from related sample. Then we will still be using t-test, but now we will be using paired sample t-test. Now, an output. So I will try to explain this t-test output and what you should try to locate from the output and how you should try to explain. Okay, we will be doing a similar exercise in our workshop as well. So first of all, when you look at this independent sample t-test output, then we will see, first of all, we will see you will have two variables or two groups, you understand? So first of all, you will have the mean of the two groups, because you understand that in t-test we are actually looking for the mean difference, if there is a mean difference. So first of all, there will be mean. The research output that's given here, it was actually a survey on whether religion has any impact on buying behavior. Okay, so they actually had two samples. One is a group of respondents from Catholic, and another group of respondents, those who are Protestant. And these two groups of respondents were asked about a particular product, that what is the price they are willing to pay for a certain product. So the mean price the Catholics are willing to pay is $61, and mean price Protestants are willing to pay is $50.27. Okay, so we can see that the mean is different, like 61 and 50. So that's what we get from our naked eye without any testing. So when we go for t-test, we will actually try to find out that if these two means are statistically different. Okay, so when we have this t-test result, what we should ideally be look at, first of all, we should look at this t-statistic, okay, and then p-value. This is actually an SPSS output, but we are familiar with Excel output. In Excel, you can remember in the last class we have seen, Excel provides a p-value. Can you remember? Excel provides a p-value. SPSS actually provides the same p-value, but they call it significance value. Okay, so this SIG two-tailed, it's a two-tailed p-value. Okay, we will be depending on Excel in our workshops today and the rest of the days. I just wanted that you be a little bit familiar with some other outputs as well. So this is derived from SPSS. Now, if you look at these p-values, you can see equal variance is assumed. As I told you that this assumption need not to be strictly followed, that equal variance and unequal variance, because we can test both. So equal variance and unequal variance whatsoever, p-value is 0.321 or 0.347. So in both the cases, p-value is 0.3. P-value is 0.3. So that's the first thing we should look at from the bottom part. Okay. So if p-value is 0.3 and our null hypothesis was the buying behavior is same across the samples. That means Catholics and Protestants, they have the same buying behavior, or their average price they are willing to pay is same. And our p-value is 0.3. So what do you think? Should we reject our null hypothesis or should we accept our null hypothesis? P-value 0.3, should we accept or reject? Can you remember how do we take this accept reject decision? On the basis of p-value?
It's greater than the significance, so we should accept the null hypothesis.
Okay, so we basically compare p-value with significance level. And what are the conventional significance level we consider?
0.05. 5% or 0.05.
0.05 or 5%. So here, p-value is 0.3. And if we consider a 5% significance level, so this p-value is greater than the significance level or less? Yes.
As the p-value is greater.
P-value is greater. So what should we do?
Accept.
We should accept the null hypothesis. P-value is greater than the significance level, we should accept the null hypothesis. Accept the null hypothesis means the buying behavior or the price they are willing to pay across these two samples are same. There is no difference. Is it all right? Now, I just draw your attention to one point. What's the mean price Catholics are willing to pay? 61. And what's the mean price Protestants are willing to pay? 50, right? Now, if we do not do any test, I mean t-test or whatsoever, what is our intuition says? They are different? I mean, there is a significant difference or there is not? Our intuition, or intuitively we will say that they are significantly different, like $50 and $60, they should be different, yes or no? But when we go for a statistical test, we see that the difference is not significant. Okay, any idea why? Or what might have made this result? Like, apparently we are thinking that they should be different, but statistical test is saying not.
Sample size is different?
That can be one issue, but there is another issue.
I forget what the word for the term is, but it's where they're outside of that scale. So they're floating.
What's our?
Yes.
Okay, very good point. Look, we don't know whether there is outlier or not, but we can get an idea. Look. So 61 is the average price Catholic they pay, want to pay, and 50. And look at the standard deviation, this 43 and 64. Don't forget, like, we didn't learn how we practically calculate standard deviation, but don't forget the concept or the idea. If you can remember, standard deviation, as I said, that it's the average deviation of individual observations from the mean value. Okay. So, for example, in this case, mean value is 50 and mean value is 61. Now, how much the individual observations are different from this mean value? And you can see that standard deviation is pretty high. Standard deviation pretty high means the range of prices that the respondents have offered is huge, and probably there are some extreme values. Yes or no? There are some extreme values, that's why our standard deviation is very high, and due to these extreme values, we are not getting a result that we are expecting. If that's the case practically, like you are expecting a type of result by looking at the means and others, but your statistical result is something different, and you are suspecting that there could be some outliers, what you can do? Like, what else you can do? Probably maybe to get rid of or to refine your result.
Well, if you were to get rid of the outliers, you need to have a good explanation. In your report, you would say the outliers were removed because they were erroneous, or there was a data collection issue, or something like that.
Okay. So what you suggest is just get rid of the outliers. Do you have any idea how do you get rid of outliers?
Press the delete button.
Okay. Now, let's say that you have thousands of observations. The first point is find out your outliers, and the second point is get rid of that. Okay. So if you suspect that there are some outliers, then that's the simplest thing you can do is get rid of outliers. Okay? That's one. Anything else? Like, instead of getting rid of outliers, as he tried to say that you need to give a very strong explanation that you removed outliers. So if you want to avoid that, any other alternatives? Yes?
Maybe increase sample size?
Well, increased sample size is a good strategy, but sometimes that might not be feasible because you get this result when survey is done, data collection is done. Now, it's possible that, okay, let's survey 100 more people, but might not be feasible all the time. So, any alternative, like instead of removing outliers, any alternative? Yes?
Maybe considering other measurements. For example, not the mean, because the standard deviation is pretty high. So we consider mode or something else.
But, you know, t-test is basically comparing means.
Yeah.
Another simple issue, like just instead of deleting, as he said that use delete button, instead of deleting, what you can do?
I
Yes?
just don't remember the terms. I'm so tired. I said to him, I just don't remember the terms. It's the grouping, so where you can group them. So, you know, as I said to you, I don't remember the terms.
Okay, I'm not sure. Maybe grouping could be one issue, but I'm just saying another simple strategy, that is just identify the outliers, replace the outliers with the mean value. Okay, so like for example, here the mean value is 50, but you get some outliers like 100, 150, or 200. So one thing is delete them, or other is just replace them. Replace the outliers with the mean values. Okay, that's another strategy. But I agree that it's not necessary that these are all. There may be some other strategies as well. Okay, so what I'm trying to suggest you here, that when you have data, you run some statistical test and get some result, keep it in mind that your job is not done. You cannot say, well, that's the result I get from data, so it doesn't matter that whether it's consistent with your expectation or not. No, you know, our expectation is built up on our knowledge and intuition. You need to value that. So if your statistical result is sometimes different from your expectation and your intuition, then you may check if there was any error, if there were some outliers, if there are some omissions. What's the case? You need to recheck, and you may retest them. So that was an example of independent sample t-test, and this is an example of paired sample or related sample t-test. In this case, some respondents were asked that from where they will buy their engagement rings. That means, will they buy it from an internet store or will they buy it from a conventional store? Okay, and these are the responses. So these are the number of responses relating to internet store, and these are the number of responses from conventional store. So you understand? People don't want to depend on internet store. So if you go for paired sample t-test, and once again, we look at mean difference, we look at t-statistic, you can see that this t-statistic is pretty high now, okay? And you can see our p-value is now 0.000, okay? So p-value 0.000, we should compare it with significance level, yes or no? So is it less than significance level or more than significance level? It's less than the significance level, so what should we do? Accept or reject? We should reject. We should reject the null hypothesis. In this case, null hypothesis was that people have similar preferences in terms of internet store and what's called conventional store. People have similar preferences, but we see that we reject our null hypothesis because the p-value is less than the significance level. So we reject null hypothesis means people's preferences towards the internet store and conventional stores are not same, like they more prefer the conventional store. Anyway, just I mentioned another point, and I said that we look at t-statistic and p-value. Okay. If you look at t-statistics minus 16, keeping in mind that when we look at t-statistic, we do not look at its sign. That means we look at its absolute value. Okay? We do not look at its sign. So it's 16. So I said that it's t-statistic and then p-value. Probably you can remember, I just remind you again, that this p-value is calculated or p-value is derived by comparing between this calculated t-statistic with a critical t-statistic, as I said in the last class. So in this case, critical t-statistic is not given because this 16.01, that's only our calculated t-statistic. That's why we cannot decide or we cannot take an inference on the basis of t-statistic, so we look at the p-value only. However, if you have the critical t-value, then you will find that this calculated t-value is greater than the critical t-value because your p-value, that's a calculation process, your p-value can be less than the significance level or p-value can be close to 0 only if your calculated t is greater than your critical t. Okay? So calculated t greater than critical t, you should reject your null hypothesis. Similarly, your p-value less than the significance level, you reject your null hypothesis. So if your inference is based on t-statistic or p-value, you should have the same conclusion. They will never create any conflict between, because p-value is calculated from a comparison between this t and critical t. Why I'm saying critical t? Because when we go for Excel, that produces us both the t calculated and the critical. You will see that you can generate a 0 p-value only if your t calculated is greater than your t critical. Is it clear up to this? But if you don't want to complicate the situation, you can simply make your decision on the basis of p-value. Compare it with significance level. If less, reject. If more, accept.
I have a question.
Yes.
How long did it take you to learn this? Because I feel like it's filtering through my head.
Have you had a chance to read the textbook and in the chapters?
Yes.
So you have the concept is like t-test, critical t.
There's just a lot of terms to remember.
Yes. I am not expecting that you remember everything. So what you need to do is you need to have an understanding of the t distribution. So we get a critical t value on the basis of our significance level. You can remember we said that we have some theoretical significance level like 1%, 5%, and 10%. For the simplicity, let's say that 5%. So for 5% significance level, you have two specific t-values. Okay. Now, we don't need to remember these critical t-values, but previously we had to. But since now we get the results from our software, so we don't need to remember that. So in this case, when your significance level is, for example, 5%, you know that for 5% significance level that there is a benchmark t-value. Okay. And if this is your calculated t-value. So if you have a distribution, then you know where is your benchmark t-value, and this is your calculated t-value. Since it's higher than the benchmark, so it should be outside this benchmark t-value. As a result, you are rejecting. Okay. So previously, what we used to do is we used to remember what is the benchmark t statistic for 5%, for 10%, and we calculated this t statistic so that we can readily say, okay, my calculated t statistic is this, but benchmark t statistic is this. That means it's outside the range, so we reject our null hypothesis. And if it is less than the t critical, then it's inside the range. That means if you think about the distribution, then it's inside the range, so we accept our null hypothesis. I understand that this concept will take some time to grasp as you go on with the reading. But if you want some additional reading,
I really don't want to.
you don't want?
I appreciate the offer.
The textbook that we are following, my understanding is it's like written in a simple way. So
it's simple, but the problem is that because I have just read 3 chapters,
Mhm.
I was behind, and then it gets to a point where it says, you don't need to know this because basically this is what the software program does. And I just went, oh my God.
yeah, actually what you need to do is you don't need to know how actually it's calculated. You just need to know that what is this. For example, what is mean? You don't need to calculate it, or what's a standard deviation, or what's a t-value. Just understanding that is enough, because those will be produced by the softwares. And that's what I was discussing in the last class, that's why this type of discussions or lecture has nowadays a little bit difficult, because like when I was a student, we used to practically calculate everything. For example, this t statistic, p-value, we practically calculated everything, used formulas, there was big equations, we practically calculated them. Well, that was time consuming, but that gave us a hands-on experience what's actually we are doing. But nowadays, since the software is giving all these results, we say, okay, you don't need to calculate them, just understand the concept. But sometimes, these are the technical issues. Without practically calculating them, understanding the concept, there is always a gap. Like this is practical and this is what we theoretically learning, there is always a gap. So yeah, you need to just read more and more to get the concept. So far we talked about chi-square test, t-test, now another bivariate test, that is ANOVA, analysis of variance. So far, you have, I think, understood that when we are using t-test, we are comparing means between 2 variables or between 2 groups. Now, what if we have multiple variables or multiple groups? For example, as I said, that whether income level is different between male and female, or income level is different between gender or marital status, or just 2 groups, then t-test is fine. Now, if you have multiple groups, for example, if you are testing customer satisfaction across different age groups, like you have 5 age groups, if you want to check customer satisfaction across different income level, so you have 5 income level groups, in that case, t-test is no more suitable. Why? Because as I already have said, the t-test compare only between 2 variables or only between 2 groups. Now, if you have multiple groups or multiple variables and you want to compare if there is a mean difference, then the suitable test is ANOVA, analysis of variance. So, t-test and ANOVA, they have some similarities, but the key difference is they have the similarities because both tests are the test for comparing means. So we compare if there is a mean difference. So that's the similarity between t-test and ANOVA. However, the difference is t-test is for two variables or two groups, whereas ANOVA is for multiple variables or multiple groups. I understand that you might have a question in your mind that, as we said that we are talking about bivariate analysis, and we said that bivariate analysis means that it involves two variables. So we are talking about the statistical techniques that involves two variables. So far we are talking about two variables. Now I am saying, okay, ANOVA is suitable for when we have multiple groups or when we have multiple variables and we are comparing means. So you might have a question in your mind that why ANOVA is here. It should be included in multivariate analysis. Yes or no? Any idea why we are discussing it here? Okay. Actually, when we are using ANOVA, we are comparing means of multiple groups or multiple variables. That's fine. But when we reject our hypothesis, then what substantive conclusion we make is, you can see at the bottom of the slide, at least one group mean is not equal to another group mean. Okay, this is important because if we go for a null hypothesis, for example, customer satisfaction for group 1 equals to customer satisfaction, group 2 equals to customer satisfaction, group 3 equals to customer satisfaction, group 4, if we have a null hypothesis like this, and if we accept our null hypothesis, then the conclusion is the customer satisfaction across 4 groups are same. It's fine. Now, if we reject our null hypothesis, customer satisfaction group 1 equals to group 2 equals to group 3 equals to group 4. If we reject our null hypothesis, what conclusion we make is at least one mean is different from other mean. That's why it's under the bivariate test, because although there are multiple groups or although there are multiple variables, but we are comparing with each pair of variables. Okay, that means we are comparing, for example, between A and B, B and C, C and D, D and E, A and E, A and D in this way. That means each pair. Do you get my point or not? We are comparing whether the mean is different in each pair. Okay, so when we find that the null hypothesis is true, it means that all the pairs, all the means are same. But if we reject, when we reject our null hypothesis, it does not necessarily mean that customer satisfaction group 1 is not equal to group 2, not equal to group 3, not equal to group 4. No, we do not say that all are different. What we say is at least one mean is different from other mean. That's what our analysis of variance tells us. But if I just formally tell you that when we should use our analysis of variance, then those conditions are very similar to the t-test. For example, analysis of variance can be used when you have multiple variable and they are ratio scaled. Okay? Multiple variable and they are ratio scaled, or you have one dependent variable and that can be divided into multiple groups on a categorical variable. That means, let's say income level, and you divide it into 5 groups. Let's say age group, you divide it into different age, you divide it into different groups. customer satisfaction, you divide it into different groups. So you have one dependent variable and you divide it into multiple groups. That's why. Or you have multiple variables, 4 or 5 variables. Okay. So these are the first condition, and the second condition is when you are dividing your dependent variable using a classificatory variable, those classificatory variable should be related to your research question that we have discussed earlier. Okay. So you understand that the conditions for analysis of variance and conditions of t-statistics in terms of the ratio scale is same, because t-statistic and ANOVA both have to be used if there is all the variables are ratio variable, or at least one ratio variable is divided into different groups. So if I show you an example, okay, before the example, just a little more discussion. When we calculate ANOVA statistic that we call F statistic, basically we try to find out 2 variances. One is between group variance, another is within group variance. Okay, so if you understand that ANOVA is used when we have multiple groups. Now, these multiple groups, we are comparing mean. So there will be one grand mean. Grand mean means the mean of your entire sample. And then you will have one mean for each of the group. Yes or no? Like, let's say that your variable is customer satisfaction. Now, if you calculate what is the average customer satisfaction in your total sample, that is your grand mean. Now, your customer satisfaction is divided into 5 age groups. Age group 1, age group 2, age group 3, age group 4, and age group 5. So for each group, there will be one mean customer satisfaction. Yes or no? So that is your group mean. So what first of all we will be calculating is, if this is our grand mean, that means the mean for overall sample, and if these are our group mean for each of the group, what is the variance from this grand mean to each of this group mean? What's the variance? We will sum them up. That's one variance. That we call variance between groups. Then for each group we have one mean, and within each group we have some observations from which the mean have been calculated. So there is mean and there is observations. We calculate how these individual observations are varying from the mean. We find out the difference and we sum them up. That we call within group variance. So we basically get 2 variants. One is between group variance, another is within group variance. And once we have these 2 variances, then we go for a test that we call F-test. So F-test is basically, the F statistic is calculated in this way, variance between groups. So we calculate the variance between groups, that's the numerator, and the variance within the group is denominator. So we get an F statistic. Similarly, this F statistic is calculated with a critical F value from the F distribution, and we get a P value. If this P value, once again compared with the conventional significance level, and we decide that whether we accept the null hypothesis or we reject the null hypothesis. That's the theoretical discussion. Now let's see a simple illustration mathematically. Under which circumstance ANOVA is used and how we actually calculate it. So here, what we have is, look at the data table below that describes how much coffee respondents report drinking each day based on which shift they work, day shifts, second shifts, and night shifts. So here, some respondents were asked that how much coffee they consume when they work in different shifts. Okay? So there are 3 different shifts. One is day shift, second shift, and night shifts. So they are responding that, for example, respondent 1 is saying that when he or she works for day shift, consume 1 coffee, when works for second shift, consume 6, and when works for night, consume 6. So these are actually 5 respondents working in day shift, the same respondents are working in second shift, same respondents are working in night shift. So they are providing their responses that how much coffee they consume when they work in different shifts. Okay? Now, so this is our total sample. So if this total sample, this day shift, second shift, and night shift, if this total sample is divided into 3 groups, then what we get is day shift, second shift, and night shift. So we get 3 groups. Okay? So what as I said, that first of all, we will calculate the variance within group. So to do this, what we will be doing, look, we have this total sample. If we calculate an average for this entire sample, so what we get is the grand mean. That means average for this entire sample is a grand mean. And for each of these shifts, for example, if we calculate an average for day, average for second shift, and average for night shift, so what we get is the average for each shift. Okay, so that is our group mean, as I was trying to say. So we have the grand mean and we have group means. Okay, so if we now calculate what is the deviation from this group mean from the grand mean. Actually, grand mean is, for example, 4. That means if we calculate the mean for this entire sample, then it is grand mean. And if we are calculating mean for each of these shifts, then they are group mean. So if we calculate that how this individual group mean is different from this grand mean, if we take the difference and we sum them up, that we call variance between the groups. Okay, that's one. Another is for each group, you can see that, for example, for day shift, the mean is 2. Am I right? But what are the individual observation in day shift? 1, 3, 4, 0, 2. These 1, 3, 4, 0, 2 are the individual observation, and the mean is 2. Now we can find out what is the deviation from this individual observation from this group mean. If we calculate for each of this group, what we get is variance within the group. That means how individual observation within the group is different from the mean. So we get variance between the group and variance within the group. Once we have these two, we calculate F statistic and we compare it with the benchmark F statistic and we get the p-value, and the rest of the decision process is same. So if you see this diagram, then what we get is, this is actually the same information. That means this information is reported in this diagram. So first of all, this is the day shift. That means these are the day shifts, these are the second shift, and these are the night shift. So what we have is, this is the mean for day shift, and this is the mean for second shift, and this is the mean for night shift, and we have an overall mean. So as I was saying, that we calculate the variance within group and variance between the group. So when we are talking about variance between the group, what we have is, there is a grand mean, and what's the difference between individual mean from this grand mean? That's the variance between the group. And for each of this group, for example, this is the mean for night shift. For each of this group, there are some individual observation, and this is the mean. So what's the difference between individual observation from the mean? That's the variance within the group. And from this variance between the group and variance within the group, we calculate F statistic the way we calculate a T statistic. Then we compare with the benchmark and we get the p-value. And once again, if p-value is less than the significance level, then we will be rejecting that there is no difference among the groups. We reject this null hypothesis. It means that there is a difference. Now, if I just tell you one statement, let's see whether you can explain this statement or not, that analysis of variance, that means what we are discussing here, analysis of variance is a special case of a t-test. Can anyone explain this sentence? Analysis of variance is a special case of a t-test. I'm just telling you to give you a little more understanding about what's the difference between t-test and ANOVA. Anyone? Analysis of variance is a special case of a t-test. Okay, what's the main difference between analysis of variance and a t-test? What's the main difference?
The t-test is only got 2 levels.
T-test is only for 2 groups or 2 variables, and analysis of variance is for multiple groups or multiple variables, right? Now, analysis of variance for multiple groups or multiple variables, if we run this test, that means analysis of variance, if we run this test for 2 variables, I understand that it's for multiple variable or it's for multiple groups, but if we run this test, I mean analysis of variance, if we run this test for 2 variables, then we get the same result we get from t-test. Because, as we said, the t-test is actually a test of comparing means between 2 variables or 2 groups, but analysis of variance for multiple. But practically, it's possible that when you are doing analysis of variance, you just have 2 variables. I understand that when you have 2 variables, you should just go for t-test. But if you do ANOVA, for example, you have 2 variables, but if you do ANOVA, you get the same result that you get from t-test. So the main difference between ANOVA and t-test is the number of variables or number of groups you compare. The other condition, that the ratio variable or ratio variable have to be divided based on 2 classifactory variable, these conditions are same. Any question, any problem up to this? So if we have a look at an ANOVA result, so as I already have said that when we run an ANOVA, we actually get an F statistic, which is compared with a benchmark F, and we get a p-value. So this is the result that we get for the ANOVA that was done for the example that we have seen. That means we have 3 shifts, day shift, second shift, and night shift. So we have 3 means 2, 4, and 6. So what we have is, first of all, at the top, you can see we get an F statistic that is 4.4, and we get a p-value of 0.039. Once again, this is a SPSS output, but in our workshop session we will see an Excel output as well. So our p-value is, F statistic is 4.4 and p-value is 0.039. Okay? So if our p-value is 0.039, what do you think? What is your decision about the null hypothesis? Okay, so it's 0.039, so it's less than the significance level, 5% significance level. So we reject the null hypothesis. And you understand that p-value, it can be, for example, 0, 0, 0. You reject the null hypothesis. Now if your p-value is, let's say, 0.045, you will still reject the null hypothesis because it's less than 5%, less than 0.05. But p-value closer to the significance level, it means that the rejection is weaker. And p-value is away from the significance level, it means that the rejection is stronger. For example, if your p-value is 0.00 and you reject the null hypothesis, we actually explain it in this way, that the null hypothesis is strongly rejected because p-value is 0 and your significance level is, let's say, 0.05. Now, if your p-value is, for example, in this case 0.039 or it's 0.04 or 0.05, so mathematically they are less than 0.05, I mean less than the significance level. So we reject our null hypothesis, but we explain that the rejection of this null hypothesis is weaker, or we just say that we marginally reject the null hypothesis. Okay, that means the rejection of the null hypothesis is weaker. Okay, so when you explain your result, it's all right if you just write that we reject our null hypothesis, so they are same or they are not same, or we accept our null hypothesis. But if you can add some additional points like we strongly reject or we marginally reject, or the evidence of rejection is stronger or weaker, that will actually give an impression that that's your better understanding of the results. So that's the end of our discussion session today. And in our workshop session, we will see that how using our data we actually can test this and how we can interpret our result. I would suggest that try to have a look at the questions in your assignment and try to have a look at the workshop question that we will be solving. So try to relate your assignment question with your workshop question so that you understand that under which circumstances we are using which statistical test. That will give you a more clear idea that what statistical test you should be using for answering your assignment questions. Okay? So try to relate them. So we will see after 5 minutes in the computer lab.
That's a good question, please. Maybe I've missed something. The 5% p-value, where's that?
5% is the significance level. So it's actually like it's a conventional label. That 5% significance level means you are accommodating a 5% chances of error.
Because your confidence level is 95%.
Confidence level is 95%. So it means that you are 95% confidence that the inference you are drawing is true. Okay. So it means that, for example, you have a null hypothesis that this is equal to this. When you are taking a result and you say that, okay, I accept our null hypothesis. So, and it's 5% significant, 5% significance level and 95% confidence level. So you agree that this is equal to this, but they may not be in 5 of every 100 cases.
Yeah.
So it's not that it's always true, but there is 5% chances of error.
Yeah, that makes
But
sense.
it's not like 5%, it's not the only significance level. So we use 1 to 10%. For example, sometimes we use 1%, sometimes we use 10%. And nowadays some researchers are arguing that, well, what significance level we should use basically depend on the size of the data. Because if we have a smaller data, then it's all right to use, let's say, even 15% or 20% significance level. But if you have, because when you have a smaller data, there is more chances of error. But if you have a large data set, for example, now when we are doing some like finance type of research, we have millions of observations, and in that case, they are arguing that it should not be even 1%, it should be even less than 1% significance level, because when you have huge data set, you cannot accommodate that there will be 5% error or 10% error. So it's actually a convention that what's the level of confidence or what's the level of error you accommodate.
So they'll give it to you at sometimes it's given to you.
Yes, that's conventionally used.
Yes.
That's conventionally used. For example, even when you're doing research, like we present some result, we show the significance 1%, 5%, and 10%. We show all the three.
Yeah,
So we
okay.
say that, okay, this result is significant at 1%, or
Yeah,
this is
okay.
5%, or
Yep.
this is 10%. So when we say it's 1%, it's more stronger result, and when it is 10%, is more weaker result, because 10% means there is a good chances of error.
Sure.
Yes.
No worries. Thank you.
take for example, you know, what would you use on
Hello. Didn't see you there. I thought I saw you. You saw me? Yeah. Because she was wearing a gym gear. Oh, yeah. No, I haven't had my gym gear on for a couple of weeks. It's been so busy. Redoing my daughter's bedroom. My daughter's bedroom.
Oh, really? You're just doing it.
Like carpet, paint, furniture. Trip to IKEA. So yeah, I'm just been reading, trying to prepare for tomorrow's class.
How many exams do you have?
3. It's just so stressful. Yeah. Hello. Cold, isn't it? Beautiful outside.
I bet they should know that everyone's done like the same.
That's what it is.
They hate it.
Are you going to sit up front?
You go to Vietnam, they're so funny. Because their mask is like people are wearing a mask and the mask would have ears to cover the ears or the neck. So funny.
Yeah, because they want to keep
That's
their
their
white
hair.
Moisturizer on.
You are please in alphabetical order. I've got a problem with this unit.
Why?
The marks are so high.
Oh my God.
Eh? I've got a problem. I'm serious. They're going to say to me, how's it possible?
Imply that you're a good teacher.
You
have excellence. Yes.
You know, no, I'm serious. I mean, you know, and you know, I can tell you that your 2 assignments, I had a benchmark against which to write against. It's not that I was giving it away. I mean, you know, my benchmark was a CA program.
You do what you have to do.
Eh?
Worry about it.
I do have to worry about it. Because there are some people who are going to say, how is it possible?
No, you need to start worrying when at the end of the exam when everybody gets an HD and then you go, oh, now I'm in trouble.
You know, in those questions where I asked for comprehensive examples, that meant I wanted every cost pool, every cost driver. That's one area where people didn't read the word comprehensive. Okay, so please look out for those things. Have any of you looked at the slides for today yet?
Yes.
Right?
Not yet, but you've changed them on me anyway.
You know what? Do you know how many slides the textbook had for today? 3. So the authors had 3 slides. That's it. Not very imaginative, is it?
back to this.
I have no printer at home. It's driving me.
You still got no printer?
insane.
I have a printer, but no.
I have a broken printer. And I don't have time. I can go and buy one. That'll take like half an hour.
You go buy one.
Yeah, but that takes ages. And the last one did.
Did you hear about this woman in Canberra who was killed by her dog?
No.
She knew that dog was dangerous, eh? What a way to go.
What? With her own dog?
Yep.
Wow.
I hated section 3.
You know, I'll tell you where students did very well was on the numbers. All right?
Everything else I got from last time except for section 3.
Section 3. The last one.
2 short time. No. Section 3.
Are you Umar? Yep. No, there's the other one. Is anybody here that still hasn't got the first one back? I keep on, every week I carry it with me.
The shortcomings of
Yeah, the first assignment. Yeah, welcome back. Well, you've been back to Germany on holiday.
Maybe.
Maybe.
No, no.
What is your name?
Martin.
Before the numbers.
Before the numbers, yeah.
How do you pronounce your surname?
Hartwig.
Sorry?
Hartwig.
That sounds Czechoslovakian.
No, it's all Polish.
Polish.
Yeah.
Close.
Yeah, close.
Close. Pretty close. The other one. Anybody else that still hasn't got? May I suggest that you guys sitting at the back come a bit closer? I have got deodorant on.
We won't bite.
Sorry?
And we won't bite.
And you won't bite. That's one thing about my dog. My dog could never bite. You know why? I'll show you. You think any of these guys could bite? Anybody?
No, they're my mum's favourite as well. The Cocker Spaniel.
You see, we've got, my wife, my son and I, we've got a mixture of this one and that one. So he's actually a Cavalier mixture. So he's got this, but he's got a white chest. Right? Then he's got one gold leg and he's got one white leg. Then he's got half of the tail is black, half of the tail is white. Could they bite? No chance. No chance. Okay, class. What I'd like to do, I'd like to do a question on. It's not 7 o'clock yet. Okay.